All right, so today we are looking at a little introduction to rotations. So a rotation belongs to this broader category of a rigid transformation. So to be a rigid transformation, that just means that we are altering the place and position, but we still keep the same size and shape. So the original figure pre-image and the resulting figure, the image, they stay congruent. So we've already covered the other two. We've talked about translations. We've talked about reflections. So today is the big day for the rotation. All right, so here in my picture, I'm giving you an example. So for a rotation, each point moves the same distance and degree measure around a center of rotation. So in my picture, the center of rotation ends up being right here where point P is. So this is the center of rotation. So in my visual here, we are seeing that our triangle is moving 90 degrees to the left. So it's going against the clock, which means it's going counterclockwise. So rotations can be clockwise or counterclockwise. I usually abbreviate with a little C or double C notation. So if we're going clockwise, we're going with the clock. So everything is veering to the right. And counterclockwise, we're going against the clock. Everything is veering to the left. Okay, and what's happening is that each point, the distance to the point of the center of rotation, that point P right here, is staying the same. So if we look for A, right, it swings into this position here, A prime. Same would be true for B and C. If I connected here from P to B and P to B prime, that distance would be the same. So for what's marked in the picture, I'm just going to acknowledge that PA, that segment, is congruent to PA prime, that segment. So their measures would be the same. And before I get too deep, I just want to remind you what it looks like visually. So here is my original triangle. I have it up here in the upper right-hand quadrant. So if I want to rotate, here I'm seeing it rotated to the left. So against the clock, it would fall into this position. Let me show you how that would work. So if I rotate it 90 degrees to the left, right, that is the position that it would find itself in. That's against the clock, so counterclockwise. Okay, but if I'm starting here again and I rotate it with the clock, so clockwise, it would end up in this position right here. Okay, so again, if I pull it back, here's the center of rotation. This triangle 90 degrees to the left, so counterclockwise would go to here. Okay, 90 degrees clockwise, so with the clock to the right would land us over here. So you can always see that pretty clearly using any patty paper. And then today we're going to jump on the coordinate plane to see it another way as well. All right, so now we're getting up on the coordinate plane. So follow each set of directions. Let me get in really tight. I know that whenever we are on the coordinate plane, it can be hard to see if I'm not zoomed in. So let me get in real tight. Okay, so follow each set of directions. So first up, it's saying, well, graph these two lines, y equals x, y equals negative x. So what's nice about those two, well, we can see that they are perpendicular to each other because their slopes are opposite reciprocals. So let me graph y equals x. So I start at the origin, my slope is 1. Okay, connect the dots, draw in that pathway. Okay, y equals negative x, my slope is negative 1. So down 1, right 1 from the origin. And here we go. So again, the reason that I am showing you these two pathways, again, we know that they're perpendicular because their slopes are opposite reciprocals. It makes it easier for us to visualize that rotation of 90 degrees. So here I'm saying first, let's do 90 degrees clockwise. We start with a point that's at 6, 6, so right here. So if I'm going clockwise, I'm going with the clock. So I'm going to the right. So this point here would swing into this position right here. Here would be A prime. Okay, so again, just a reminder that this slope here, right, would be the opposite reciprocal of this slope right here. Okay, so that helps us just to visualize how we are rotating 90 degrees clockwise. Okay, I also usually label my lines, so let me just go ahead and do that as well. So this was the y equals x, y equals negative x, and then my point, A prime, was at 6, negative 6. Okay, one other way to visualize is to picture this little L shape. You're going to see me draw this quite a bit today. So to get to A, right, we're going up 6 and right 6. Okay, so I'm picturing that kind of L shape, and I'm going to picture it rotated 90 degrees to the right, clockwise. So what I went up, I'm going to go over, so I'm going over 6. And what I had gone over, I'm going down. Okay, so it just confirms that there's my A prime in that location, 6, negative 6. All right, next problem, very similar. So here I'm starting with graphing y equals 4x and y equals negative 1/4 x. So again, those slopes are opposite reciprocals, so we know that they are perpendicular pathways. So the first one, starting at the origin, up 4, right 1, up 4, right 1, that is this pathway. So that was y equals 4x. Okay, and then the other one, let me go back to the origin. Down 1, right 4, down 1, right 4. All right, so here is my second line. Again, we know that they're perpendicular at the origin, right angles all the way around. So here is y equals negative 1/4 of x. All right, so now we're going to plot point B at 2, 8. So right here, there's my B, but I want to rotate it counterclockwise, so against the clock. I usually show a little double C like that. So I'm making everything go to the left this time. So I can see that this point will rotate into this position right here. So here would be my B prime. So I can see B's location, right? I can see that B prime is at negative 8, 2. But again, if it helps you to visualize with that little arm, let me draw it in. So to get to B, we went up. Let's see. Oh, I plotted it in the wrong spot. Let me make sure it's in the right spot. Should be right there. All right, so we're looking at 2, 8, so right there. So that 2, 8 becomes negative 8, 2. Okay, so here if I draw in that little arm, so here I'm going up 8 and right 2, so right here. And then I'm picturing it swinging to the left. So right here I'm going left instead of up. And then that little arm right here, instead of going over, I'm going up to get to that new position. So again, there's nothing wrong with finding a new way to visualize it, right? This is just a new way to visualize it if you look at that little arm. Okay, next up, here I have triangle fox. So I've already plotted it for you as a little time saver. And I'm saying let's rotate clockwise without the rule. Well, I haven't shown you a rule yet, so this is the only way you probably know how to do it right at this point. So without a rule, let's use that little arm that I've been building. So if I look at point F first, so here is F, okay? So here's the origin, that's the point that I'm always rotating around. So I want to go clockwise, so I'll probably just anchor myself here. 90 clockwise means I'm going to the right. I'm going with the clock. Okay, so here, let me start with the F. Okay, so I'm going up 1 and right 2 to get to F. So to get to F prime, right, everything is swinging to the right. Instead of up 1, I'm going to go right 1. And then instead of right, I'm going down 2. So right there will be my new F. So right here will be my F prime. Okay, let's do O next. I'll use a different color. So for O, I'm going up 8 and right 4. So instead of up, I'm going to go over. So to the right, 8. And then instead of over 4, I'm going down 4. So that puts me right here. Here's my new O, O prime. Okay, the last one I have to move. I'm looking at X. So for X, I'm going up 3. And I'm going right 9. So now I need to go right 3 and down 9. Okay, so I'm leaving them in the picture just so you can see that swinging arm. Okay, so over here would be my X prime, and then I can connect my dots. So a good tell that you've done this correctly is seeing that your figures still remain congruent. And congruent is just like a cookie cutter, right? I should be able to pick one up and overlay it with the other one perfectly. All right, so here's my resulting figure. I can tell that with that prime notation. So every point has rotated, same distance in the same direction, around the origin as the center of rotation. Okay, to help you see what the rule is going to be, let's say that I pick one of the points. So if I focus on F, F was 2, 1. Okay, where did it rotate into? Well, F prime ends up being 1, negative 2. Can we see a rule based on this? So if we do, right, we're looking at X, Y, we're saying it applies to all of the points. And then what is happening? Well, if I look over here, I see, well, X and Y have switched position, and I see that what my X value is originally is switching to the opposite sign. So I'm going to start off by switching positions. Okay, and then like I said, the X values are switching to the opposite sign. So negative right here. So this is going to be the rule, and I'll formalize that for you on the flip side. So on that second sheet. All right, the next one, we're going to do 90 degrees counterclockwise. So we're going against the clock, and same thing. I'm not telling you a rule yet. I want you to see how to do it kind of mechanically. All right, so first up, we are going again against the clock. So everything is going to veer to the left. So I know it should be somewhere in this quadrant right here. So if I focus on F first, so I'm going up 1 and right 2. So then I'm going to go left 1 and up 2. So I'm picturing that little arm swinging around this point to the left. So my new F will be right here. Here's my F prime. Okay, let's do O next. So for O, we are going up 8 and right 4. Okay, I'm picturing that little arm swinging to the left. So I'm going left 8 and up 4, right there. So here's my new O, O prime. And then lastly, I need the X. So for X, I'm going up 3 and right 9. So I need to go left 3, and up 9. So right there. So right here is my x prime, and then I can connect my dots here, here, and here. All right, so again, we've rotated around the origin as our center of rotation. Okay, I showed you how to do it using that little swinging arm. And if I'm trying to figure out a rule, let's go back to point F. Right, it started at 2, 1. Where did it finish? It finished at -1, 2. So if I want to build a rule off of that, here's x, here's y, arrow to the right. Well, I can see that the x and y have switched positions, but I also notice that now the original y has switched to the opposite sign. So my rule is going to be -y(x). All right, let me zoom out for a moment and look at the two problems together. So look at what is happening here. When we look at our rules, we see that x and y have switched position, but we see that over here it's the x that is taking the opposite sign, and over here it's the y that is taking the opposite sign. So what I think is a nice way to remember is you see how the clockwise is swinging to the right. Well, it's the variable on the right that takes the negative, takes the opposite sign. Okay, over here for counterclockwise, right, we see that it's swinging to the left, right, swinging to the left, and it's the variable on the left that takes the opposite sign, right? We see it looks like a negative, but it reads as just the opposite sign. So a negative becomes positive, a positive becomes negative. So again, I'm just pointing out little patterns along the way. All right, let's look at the other side. Okay, so here is my second sheet. And again, anytime we have a graph, I always try to get in real tight. So I think this looks good because we can see it all. Let me get in just a little tighter. Okay, so I'm looking at one at a time. So if I'm looking at that first one, we know that triangle rat is graphed along with its image. So we're looking at a 90-degree rotation that is counterclockwise. So we're going against the clock, right? And that means that we are going to the left like so. And we can see that. So one thing that I just want to remind you of is if I look at my center of rotation, let me get a color. So the origin. So if I look at one of the 3 points, it could be any of them. Let's say we look at the R's. So here and here. Okay, we're seeing that the distance from the center of rotation to point R and to R prime is staying the same, And I can see that right angle right in here. So I could do the same thing to the T's. I'd see the right angle. If I did it to the A's, I'd see the right angle and know that that distance is staying preserved. All right, so if I quickly fill in my image points, R prime will be -3, 2. A prime will be -8, 2. T prime will be -8, 6. So what is my rule? Right, remember they're going to switch positions, but not just switch positions. Which direction is it swinging? It's swinging to the left. The one on the left takes the opposite sign. So -y(x). So that is my rule for a 90-degree rotation against the clock, counterclockwise. All right, let's look at the next one. So here we're looking at a 180 rotation counterclockwise. So I want you to think about that for a moment. If I rotate this against the clock 180, and if I rotate it 180 with the clock, right, it's going to land in the same spot. So it really doesn't matter what direction I tell you. It would be the same if it was clockwise. So same as clockwise. And I'm also pointing out that really, if I'm rotating 180 degrees, it's the same as a reflection over both axes. So I would get in the same spot if I was reflecting over the y-axis, and then the x-axis would land me here. If I reflected over the x-axis, then the y-axis, it would land me here. So the order really does not matter. All right, so here let's look at the new image points for R. So R prime is at -2, -3. A prime is at -2, -8. T prime is -6, -8. So if I look at what's happening from the original to the new for all of these, they've all just switched to the opposite sign. So our rule here is just -x, -y, right? Every coordinate is switching to the opposite sign. So positive becomes negative, negative becomes positive. Okay, one other thing to point out, let me just get a color. So if this is my origin, let's say that I pick the A's. Watch what I can do. If I connect the A and the A prime, like this, right, I can see that straight pathway that connects through the origin. And a straight pathway, a straight angle, is always 180 degrees. All right, one more variation right here. So the 270 rotation counterclockwise. So our book loves to go counterclockwise. I think it's more intuitive to think of it as 90 degrees clockwise. Okay, so we know that that means if we're following 90 degrees clockwise, it means we're veering to the right, just like so. So we can see it. So if I extract the prime points, R, A, and T, R prime is 3, -2, A prime is 8, -2, and T prime is 8, -6. So if I look at, let me just grab a color. So if I look at the origin as my point of rotation, it's the only point I will have you rotate around. Let's say that I do the same thing where I focus on the A's. So if I connect back here to the origin, and then A prime to the origin, right, I can see that that distance from the center of rotation to point A, center of rotation to A prime, that distance is staying preserved, and I can see that right angle right there. All right, my rule, again, I know that they're going to switch spots, X and Y switch, but since I'm veering to the right, that negative sign, that opposite sign goes on the right. So Y, -X. That will be my rule. All right, so lastly, perform each rotation with or without the rule. So it doesn't offend me if you would prefer just to picture that swinging arm or do it straight from your memory, that's fine. I'm just giving you strategies in case you get stuck. So if you like to do it just straight from the graph, that's fine. If you like to see the rule and you plug in, that is fine too. All right, so I'm saying a 180 rotation counterclockwise about the origin. But again, that's really the same as if we went clockwise. So same as 180 clockwise. Okay, so same difference, right? 180 rotation, whether we go clockwise or counterclockwise, we're going to end up in the same spot. Also, just a reminder that it's the same as reflecting over both axes, the X and the Y axis. Okay, so my rule for it, we saw it up above, so we know that we're looking at each ordered pair and we're switching them to the opposite sign. So since I've already shown you how to do things manually, right, with that swinging arm, I'm going to show it by just plugging into a rule. So if I'm plugging F into this rule, the X and the Y switch to the opposite sign. So F prime will end up being +6, -5. O prime will be positive 2, negative 4. X prime will be positive 3, positive 1. So now I'm ready to just go ahead and plot those points. So 6, negative 5 puts me right here. So I know that that is my F prime. O is at 2, negative 4, so that puts me right here. So here's my O prime. And then X is at 3, 1. So here is my X prime. So now I just connect my dots. And then here is my 180-degree rotation, right? We could call it clockwise or counterclockwise, either way. But here, if I take my ruler, let's say that I connect the F's. See that straight pathway that passes through the origin? Same with the O's, and same here with the X's. So I'm just doing a little visual check to make sure that I've plotted every point correctly. All right, last one. Let me slide it over. So here I'm given a rule. So if I don't remember what that rule says, I could always just apply it to these points first. Okay? I do happen to know what that rule is since we just reviewed it. So here we see that X and Y switch positions, and the negative is going on the left-hand side. So that tells me that this is a 90-degree rotation. And we're going against the clock. We're going counterclockwise. So everything is veering to the left. All right, so let's say that I'm applying the rule. So my P prime, I'm going to want the I prime and the G prime too. So what's happening? The Y's are going first and they're switching their sign. So I'm going to block out all those X's and look at those Y's for a moment. So 1 goes to negative 1, negative 3 goes to positive 3, negative 5 goes to positive 5. Okay, and then all of the X coordinates just go next. 3, 8, 4. All right, so let's plot those points. So negative 1, 3 right here. That will be my new P prime. Okay, I becomes 3, 8. So 3, 8 gets right here. So there's my I prime. 5, 4 puts me right here. Here's my G prime. So if I didn't identify the rule initially, I should be able to see it now. That all of the points have rotated 90 degrees to the left around the center of rotation, which is the origin. And again, another thing I can do to double check that everything looks right is I could always connect, let's say I do the P's, here P prime to the origin and P to the origin, right? I could do it with all of them, the I's and the G's. I should be seeing that these segments are congruent, right? Their measures would be the same, and that there's my right angle. So I'm just doing that as a nice little visual check. Does it all make sense? And it does. All right, that's all I have for today. Have a good rest of your day.